gas happens to be surrounding us, even in our own body. It is so hard to exactly describe about real gas behavior. Therefore, scientists created the concept of an ideal gas. We can call the gas molecules as ideal gas when they only interact with each other. The collisions between gas molecules is perfectly elastic, and we can neglect their volume comparable to the space they exist inside of. Ideal gas equation. P is the pressure in unit of Pascal. V is the volume measured in unit meter cube. N is the number of moles, unit mole. R is the universal gas constant in the unit joule per Kelvin per mole. And T is the temperature measured in unit Kelvin. Let's have a look at the relationship between pressure and volume first. As you can see, the other values become constant. Therefore, pressure is inversely proportional to the volume. And the graph will be looked like this. Imagine that you have a sealed container in a closed system. When you squeeze the container, the space for molecules to move inside it becomes tight. More collision per unit area happens. Thus, the pressure is increased, and vice versa. By mathematically, we can write it as P1 V1 equal to P2 V2, and we call this as Boyle's law. Next, let's have a look at pressure and temperature. So we make the other values, V, N, and R are constant. Thus, the relationship between pressure and temperature is directly proportional as shown in the graph. Now, take an example of the pressure cooker. By fixing the volume of the container, the steam trapped inside it raises the internal pressure, hence permits high cooking temperature. By mathematically, we can write it as P1 over T1 equals to P2 over T2. We call this phenomenon as pressure loss. Now we're looking at the relationship between volume and temperature. So the pressure N and R become constant values. Therefore, the relationship between volume and temperature is directly proportional as shown in the graph. When you heat up a container, the gas molecules become energetic. Hence, more collisions per unit area happen. This means your pressure is increased, but we need it to be constant. Therefore, we need to make a bigger space for molecules to move inside it. Well, again, here is the mathematical equation that relates the volume and temperature, where V1 over T1 equals to V2 over T2. We call this as Charles' law. Before we end our lesson, let's do the recap. For a constant temperature, the pressure and volume is inversely proportional. For constant volume, the pressure is directly proportional to the temperature. For constant pressure, the volume is directly proportional to the temperature as well. That's all. Thank you.